Up until now, our focus in the study of circles has been on angle measure and arc measure and how those two relate or tie together. Today we're going to shift that focus a little bit and talk about lengths of some line segments. In particular, we're going to focus in on chords of the circle. All right, so on the page, there are some theorems regarding chords that you need to be familiar with and comfortable working with. The first theorem says that when two chords intersect inside a circle, the product of the lengths of the segments of one chord is equal to the product of the length of the segments of the other chord. So in other words, what this theorem is saying is that anytime I have two chords that intersect inside the circle, and I'm going to color code them so that I can talk about them. If I were you, I would recommend getting my highlighters out and highlighting. So in other words, I've got a purple chord in my circle and I've got a blue chord in my circle. The pieces of the blue chord are represented by C and D. The pieces or the segments of the purple chord are represented by segments or lengths A and B. So this theorem says if I multiply the two pieces of the purple chord together, A times B, that product is going to be equal to the product of the pieces or the parts of the blue chord, C times D. All right, so let's go take a look at how we might solve a problem that involves this theorem. In looking at example 1, again, I'm going to grab my highlighter and I'm going to highlight one of those chords green. I'm going to highlight the second of those chords blue. My theorem says that the product of the two pieces of the blue chord, 12 times x, is equal to the product of the two pieces of the green chord, or 8 times the quantity x plus 2. So in order to solve this, I'm going to go ahead and distribute on the right side of my equation. I'm going to subtract 8x's from both sides. And in order to undo multiplying by 4, I'm going to divide both sides by 4. So I find that the value of x can either be positive or negative 4. Since x in this diagram represents the length of one of the segments, x can't be negative, and I know the value of x therefore has to be positive 4. All right, so that's the first of the theorems that you need to be comfortable working with. The next set of theorems all have to do with radii and chords. It says anytime you have a radius that's perpendicular to a chord, so if I look over here at this picture, that radius is perpendicular to the chord, it's going to bisect that chord, or in other words, cut that chord into two equal parts. The reverse of that is true as well. Anytime you have a radius that bisects a chord, creating those two equal segments, you know that that chord has to be perpendicular to the radius. And likewise, the perpendicular bisector of a chord, because it's going to be a radius, has to therefore pass through the center of the circle. All right, so let's take a look at an example that utilizes these three theorems. Number 2 says, given the circle with the diameter that's perpendicular to the chord, solve for x. So my diameter is represented by the green segment. My chord is represented by the purple. Because of that right angle, I know that that diameter has to bisect the purple chord, making the other piece of this purple chord also equal to x. Some other information I know that I'm given in this question is that the radius of this circle is 5, meaning the distance from that center along that green line segment is also 5. So if one part of the green line segment is 2, and I know the length of the whole thing is 5, I can conclude that that piece must be worth 3. So now that I've got my diagram labeled, I can utilize the same idea I used in the first theorem on that page, in that the two pieces of the green chord, which are 8 and 2, their product must be equal to the two pieces of the purple chord, x and x. So x times x, the product of the two pieces of the purple chord, is equal to 8 times 2, the product of the two pieces of the green chord. Well, x times x is x squared, and the value of x squared is equal to 16, making the value of x either positive or negative 4. Again, in this picture, x represents a length. We can't have a negative length, so I make the determination that the value of x must be equal to 4. All right, a third set of theorems that you need to be comfortable and familiar working with have to do with congruent chords. The next one says anytime you have congruent chords, so in other words, if that purple chord from C to D is equal to that purple chord from A to B, they're equal distances from the center. So the distance that that purple chord is from the center is going to be equal to the distance that purple chord AB is from the center. Remember, we always measure distance along the perpendicular. So that means those blue and the purple are going to form right angles. Likewise, the reverse of that is also true. Anytime you have chords that are equidistant from the center, those chords are going to be congruent. All right, we'll see how we can apply some use of this in question number 3. It says we're given that O is the center of the circle. We're given that the length of chord CD is equal to 16. So if I go look at the picture, there's chord CD. I happen to notice immediately the right angle there at F, meaning that if the whole thing is 16, then each piece of that must be 8. Likewise, chord AB is also 16. And because of that right angle there, again, I know that each piece of chord AB has to be equal to 8. The third piece of information they tell us here is that the distance between points O and B is 10. What we're looking for, what we're trying to find here is the distance from O to F. Well, because the red chords in this diagram are equal, I know the distance from O to F has to be equal to the distance from O to E. So if I could discover or find the distance from O to E, I would also know the distance from O to F. Well, in looking at this question, I see, which I'm going to highlight in yellow, I see a yellow triangle, which happens to be a right triangle. Because I know 2 out of the 3 lengths in that triangle, I can use the Pythagorean theorem to determine the third measure. I'm going to call the length of that leg x. So you know the Pythagorean theorem says the sum of the squares of the 2 legs. So in this case, one leg is x, second leg is 8. That's equal to the square of the hypotenuse. So I've got x squared plus 8 squared is equal to 10 squared. I'm going to undo in adding 8 squared by subtracting 8 squared from both sides. So into my calculator, I'm going to type 10 squared, subtract 8 squared, and my calculator tells me 36. And to undo squaring x, I'm going to take its square root, remembering that every square root has both a positive and a negative. In this case, though, like my first instance, x represents the length of a line segment. It can't be negative. The value of x has to be positive 6. And if O to E equals 6, O to F has to be 6 as well. So that's a nice little question, and that it involves bisectors, it involves perpendiculars, it involves Pythagorean theorem. So it really pulls together very nicely many of the topics that we've studied so far this year. All right, up at the top of the next page, the next theorem that you need to be aware of is that regarding parallel lines. It says anytime you have 2 parallel lines, the arcs that they intercept are congruent. So in other words, if line segment or chord AB is parallel to chord CD, then the 2 arcs that are between those 2 line segments, in this particular case AC and BD, must be congruent. And that, I think, is a fairly straightforward one and a pretty easy one for kids to remember. So let's go see how we would utilize this. In the next example, we're given these parallel chords. So these pieces here are parallel. And if the blue segments are parallel, it's going to be the chords that are between them that have to be congruent. So I'm not sure what those are, but I do know that they have to be congruent to each other. Because the degree measure of that central angle is 40, and I know that the degree measure of the arc is equal to the degree measure of the central angle, I know that that red arc is 40. These 2 red arcs are congruent, so if one is 40, the other must also be 40. I also know that in a circle, the sum of all of the arcs has to total to 360. So I know that the purple arc plus the 2 red arcs plus the arc that measures 160 have to total to 360. So I can go ahead and write a little equation here. And then I can solve for x, and I'll know the measure of that purple arc. So I can go ahead and make the determination that the value of x has to be equal to 120. All right, so at the bottom of the page, there are some questions for you to try so that you can see if you can apply what you've learned in order to solve the following questions. Number 2, my big advice on that one would be to remember to draw yourself a diagram. If at any point you have trouble with these, that's a good indication to yourself that you missed something important in watching the video through the first time. You need to go back through there and then revisit the ideas in the video.